Hi, how are you? Now we are to divide and multiply functions. Our given functions here, we have f of x is equal to 1 over x plus 1, and our g of x is x over x minus 2. Both of them are rational expressions. This would mean we really need to identify the correct processes in dividing and multiplying rational expressions using the concepts of multiplying and dividing fractions. Let's start with this expression. You have f g of x. When you see expressions like this, you are to multiply the two functions. So our f of x is given as 1 over x plus 1. You could always use parentheses here to denote multiplication. And for your g of x, you have x over x minus 2. Now, when you multiply rational expressions, it follows the concept of multiplying our fractions, which we multiply the numerators and the denominators separately. So for your numerator, x times 1 is x. And for your denominator, you'll have the expressions x plus 1 times x minus 2. Okay? Now, since our denominator is a pair of binomials, you can still simplify that further. You will have here x as your numerator, and using FOIL method, you have x times x, that's x squared. The inner, 1 times x is positive x. Outer, x times negative 2 is negative 2x. So you have positive x, and then you have negative 2x, you have minus x. And 1 times negative 2 is negative 2. Don't forget that you cannot do this because the terms of your denominator are separated by subtraction. You can only use the cancellation law if these terms are under multiplication, to which it's not. This is already our final answer. By the way, this is also the same answer if you have g times f of x. This is because when you have something like this, you're multiplying this second expression by the first expression, or I mean the first function by the second function, and in a process of multiplication, it's commutative, so you will end up with the same result. Because again, multiplication is commutative. Let's proceed to the division. If you have an expression like this, f over g of x, you are dividing the two functions where your f of x is your dividend and g, being the denominator here, is your divisor. And instead of coming up with fractions of a fractions, because if you will write here f of x, you will have 1 over x plus 1 here, and you will be dividing this by g of x, and it might get complicated for some. Let's just simply write it like this. You will write here your entire f of x function, and you're going to multiply this, or rather divide this in this form with your g of x, which is x over x minus 2. Notice that I'm also using parentheses here so that there would be no confusions later on the process. If you have division of rational expressions to which our functions are expressed as rational expressions, you're going to use the same concept as the division of fractions using the keep, change, flip method. Okay? Keep, change, flip method allows us to keep the dividend, or we write the dividend as it is, 1 over x plus 1. We change the operation. Instead of division, you will have it multiplication. And we flip your divisor. Your second function here, your second rational expression, you reciprocate it, or you flip over x. This is now the next form. Instead of division, we have now used the keep, change, flip method, and we can now multiply them. Our result here is when we multiply our numerators to numerator. So 1 times x minus 2 is simply x minus 2. In your denominator, you're going to multiply binomial by a monomial. So x times x, you will have x squared plus 1 times x is x. This is now your form for f over g of x. But unlike our multiplication, where regardless of the arrangement of the functions, we'll have the same result, for division, it doesn't necessarily give us the same answer. g over f of x is where our numerator is the entire function of g of x, and the denominator is the f of x. Instead, we will have this one here, x over x minus 2. This is your g of x to be divided by your f of x, which is 1 over x plus 1. Okay? And then we use the keep change flip method. We keep the first to x over x minus 2. Change the operation to multiplication. So you could also use here parentheses. And you flip now or reciprocate your denominator, your divisor, to which the denominator becomes numerator and the numerator becomes the denominator. And you multiply numerators to numerators, denominators to denominators. We have x times x, x squared. X times 1, because you're multiplying a monomial with a binomial expression, you have plus x over the product of the two denominators is simply x minus 2. Notice the two answers for division. They are not the same. This supports the idea that there is no commutativity for division. And this is how we multiply and divide functions expressed as rational expressions. That's all for today. You're dismissed. And please do not forget to subscribe now.